Okay, so let's go ahead and deal with the second major reaction that CYP450 does, and that is heteroatom oxidation. This also isn't exclusive to CYP450. There's another enzyme called FMO that can accomplish the exact same thing. So heteroatoms we can do. X is our heteroatom right here, and this is going to be sulfur, nitrogen, or phosphorus. We're not going to oxidize oxygen just because you can't do that via CYP450 or FMO. I mean, oxygen, it's not going to give up its electrons to form the O bonded to another oxygen. That's just not going to happen. Okay, so P450 uses oxine, and oxine is more reactive than what FMO uses. FMO uses a peroxide-like state. Okay, so you got a peroxide. It's not as strong as oxine. That's why FMO can only do heteroatom oxidation, whereas P450 can do that plus your hydroxylation and the third reaction, which we haven't talked about, which is epoxidation. Basically, all you do is you take this heteroatom, you attach to an oxygen. The X is going to be positively charged. Oxygen is going to be negatively charged. Yeah, that's heteroatom oxidation. What can follow afterwards is you can have some chemical rearrangements in the case of a double bonded sulfur or a double bonded nitrogen. So with desulfuration, you're going to take the sulfur, you're going to attach an oxygen there, and then what can happen from there is there's a rearrangement where you can bring in water. Okay, you can bring in water, and that's going to hydrolyze this intermediate, and it's going to cut off this portion of the molecule, and it's going to eliminate that way. Your net product that you're going to end up with is a C-double-O bond. Okay, so basically desulfuration via heteroatom oxidation, it's a way to replace a double bonded sulfur with a double bonded oxygen. Similarly, imine oxidation, what can happen here is you have a double bonded nitrogen, you oxidize it via FMO or P450, okay? And then this molecule, this intermediate, it's a little more stable than the sulfur, than the oxidized sulfur. But you can still take the H2O in there, attack, and then you can cut that off. HONCH3 goes off, and then you end up, much like with desulfuration, you end up with a double bonded or C-double-O bond. Okay, so desulfuration and imine oxidation, they're just clever ways where if you have a synthesis problem, you can get rid of a sulfur or get rid of a nitrogen and convert it to a ketone or an aldehyde or just anything involving a C-double-O bond. All right, so there we have it, heteroatom oxidation.